Okay, welcome to your second video for 6-3. Um, Now we're going to actually start solving. And what we're going to be solving for throughout this entire unit is your theta, okay? So you're solving for an input. So it takes a little bit more work than just solving for, x, because x wasn't always attached to a function. To buy into this, I'm going to go ahead and graph this first. So it says sine theta equals negative root 2 over 2. So I'm going to go to my Desmos, which is right here. And I'm going to do y equals. And we just had sine theta, right? So let's go to my functions, sine. And it looks like I'll probably have x. Okay, so there you go. There's my sine wave. Hopefully you all know this like the back of your hand at this time. Let's go to our settings and change this so it looks like what we have in our notes from negative 2. Sorry, just it's a little different on my iPad. But if on your keyboard you would type pi for pi. And then my step, I'm going to do pi divided by 2. Okay, and my y's are fine. Maybe I want to zoom in a little more, but I could just do this, which is nice. Okay, I want to know when this function is equal to negative root 2 divided by, but I don't want that in there, so I gotta get out of there, divided by 2. All right, when you're looking here, it looks like, okay, well, my graphs intersect here, here, not there, here, and I'm going to go even a little further out. Let me go even more further out. Okay, looks like I have intersection here, 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 here. Do you agree that you would have infinite amount of intersections, right? Because the sine wave goes on forever, and so does a horizontal line. So this will keep intersecting. And that is why on your notes, I just want us to list 6. All right, so we could go straight to Desmos and list the 6. That is totally fine. But we might not have a calculator or Desmos when we are tested on this material. So let's use our unit circle. It looks like, okay, the first place I hit negative root 2 going in a positive direction, so I'm going this way, for sine is right here. So it looks like, okay, well, theta, that will be 5 pi over 4. There's one solution. And it looks like we have another solution here, which is 7 pi over 4. So what I'm saying there is that those angles will produce negative root 2 over 2 for sine. But I need 6, okay? So what I need to do now is maybe switch directions. Let's go this way. Well then, from there to there, that would be negative pi over 4. And then if I keep going and I go all the way here, that will be negative 3 pi over 4. All right. I could keep going, right? Because I only have 4 solutions. I need 6 more. So if I go around this circle once, that's 2 pi, right? And then I keep going until I hit here, would give me another solution. So that would give me 5 pi over 4 plus 2 pi. Find a common denominator, which would be 4. So we end up getting 13 pi over 4, right? I could do this with all of these, right? Because if you add your period, which is 2 pi for sine, it's going to get you in the same location, right? Because that's when it starts repeating itself. So my other solution could be 7 pi over 4 plus 2 pi. find a common denominator. It looks like I get 15 pi over 4. Now, because you're solving, you want to make sure you use set notation. So make set notation, especially going into calculus. Whoops. You want to make sure only when you solve for a variable, no other time do you use set notation. So I would say theta such that theta equals, and I'm going to go in order, negative 3 pi over 4, negative pi over 4, 5 pi over 4, 7 pi over 4. Oh, I have more though. 13 pi over 4 and 15 pi over 4. But it says, then come up with a general formula to find the exact solutions. So I could find every single solution out there in the world. I'm going to go ahead and get rid of this. If it will let me cut. Okay, because you don't, oh, bummer. Let me rewrite these things. We have 7 pi over 4. We have 13 pi over 4 and 15 pi over 4. Okay. Well, what we're doing here is the very first one we got was this guy, right? Going in the positive direction. So what I can say, bear with me, I can say theta such that theta equals 5 pi over 4 plus 2k pi. What I'm saying there is that I'm adding multiples of pi. But we have no idea what k is, so you have to tell the reader what k is. Now you could say, comma, where k is an integer. And this would hit all the positives that hit 5 pi over 4. It will also hit these guys because an integer could be negative. So if I do 5 pi over 4 take away 2 pi, that's going to put me in this location. Okay? The problem is that general equation does not give me this solution. So it gives me, it gives me all the yellows, so it gives me this solution. So this guy will produce all the yellow solutions that are highlighted yellow. And it will keep going, right? We just stopped because it only asked for 6, thank goodness, because I don't want to have to list everything. To come up with the other general solution, it would be theta such that theta equals the very first one you hit for the other one, which is 7 pi over 4, plus 2k pi. Again, you have to let your reader know because k could take on any value, but we want to let the reader know where k is an integer. And that will, I don't remember which color I had, will give me all of these like pink highlighted solutions because k can be negative. And remember, an integer is like -1, 0, 1, 3, 5, right? It's no decimals. If you want higher level mathematics, if you're just interested, I will never ask you for this. I could say this. Theta such that theta equals 5 pi over 4 plus 2k pi, where k is an element of z. And I could do the same for the other one. I'm just giving you more bang for your buck. I will not test you on this. What this is telling you If you remember back in the day, we know this is all reals, right? The double R. This, the double Z, is integers. And this like funky looking E means element of. Again, not part of this class at all, but just in case you want a little shorthand to write that it's part of an integer. All right, so let's try another one. Example 3. Solve 2 cosine theta plus root 3 equals 0. And I want you to list 6 solutions. So I'm going to rely algebraically to do this, and then I'm going to go to Desmos. If I have to solve for theta, I need to subtract root 3. I need to divide by 2. And now what we're going to do, now there's 2 ways to do this actually. You can now compose both sides with your inverse. And so this is very similar to like unit 7. And so right now then you would be left with just theta. And that's the whole reason of introducing the inverse, is so you can be left with your input. Because that function, you have to somehow get rid of it. And the only way to get rid of that function is to compose it with its inverse. Now realize this is very, very hard. You were the one, you introduced this. You pulled this into the equation to help you solve it. And so that is why the restrictions do not matter. Where in 6.1 and 6.2, the problems that were given to you were just, inverse cosine of 1/2. That was the problem itself. So you had to think about the restrictions. We are dealing with this equation. There is no inverse in that equation. We pulled in that technique to help us solve. So I do not care about restrictions. I will re-emphasize this in class. All right, so if I'm looking at my ugly, messy unit circle, let me get rid of all that stuff. Okay. Where does cosine, I need 6 solutions. So cosine, it hits negative root 3 if I'm going in the positive, or let's go in the negative first actually. Let's head this direction. Negative root 3 over 2 for cosine. The very first place you hit is here, which, bear with me, is, what is it, negative 5 pi over 6. All right, the next one you hit is, now be careful, don't fall for it. It's going to be negative 7 pi over 6. So actually, forgive me, I'm going to write this in order. So this one is smaller than this one. I'm just deciding to list 2 negatives. You guys could list all negatives if you want. Now I'm going to go in the positive direction. So if I go in the positive direction, I'm going here, bing, 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 bing. I hit it. So 5 pi over 6 is 1. Keep going, bing, 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 bing. And then I hit it again, 7 pi over 6. And then I need 2 more. And that's when you have to add in that 2 pi, right? Because that's adding in its period, so you would end up at the same place. So I'm going to get rid of this, because hopefully you guys are just looking at your unit circle on your own. So I have 5 pi over 6 plus 2 pi equals 5 pi over 6. I'm going to find a common denominator, which would mean I want a 6 on the bottom, so 2 times 6 is 12. So I get 17 pi over 6. find the next one. 7 pi over 6 plus the full period, because you'll end up in the same spot. Find a common denominator. And I get 19 pi over 6. So there I have 6. Now this is kind of cool, bringing in some things from Unit 5. Look at this. The negative and the positive work. The negative and the positive work. And that is because, pulling it all in together, cosine is an even function. Now, if you wanted to come up with a general formula, that would be, and let me throw this actually into set brackets to get you into good habits. If I wanted to come up with a general formula, it would be theta such that theta equals the very first one you hit going in the positive direction. You know, honestly, even in the negative direction, but just to be consistent, I'm going to go in the positive. 5 pi over 6 plus 2k pi, where k is an integer. And then the other one is theta such that theta equals 7 pi over 6, where k is an integer. Now here's the best news. I am not going to make you find, and neither will your textbook, will make you find every single solution out there. What it will do is it's going to restrict our window from 0 to 2 pi going forward. What we wanted to do here is just to emphasize that there are an infinite number of solutions, right? You can go around that unit circle so many times, infinite amount, and let me just give you the graph of this to convince you. Let me just look real quick. 2 cosine theta plus root 3. So y equals 2 cosine theta, for us it's x, plus root 3. So there's my graph. Let's talk about those transformations. So they stay fresh. My amplitude is 2, my midline's root 3, and my period hasn't been affected. And I want to know when this guy equals 0. So I'm going to put in y equals 0. And if you go zoom that in, it looks like we have this solution, this solution, this solution, this solution. So those are the two we got. This solution, this solution. And I can keep going forever and ever and ever. And I don't really want to, right? It becomes too much work. So that is why we're going to cut it off and just shrink our window. Okay, I'll see you next video.